Greetings, Moralis developers and Moralis community members. Phil here, your head of research at Moralis, and we are locking in for another exciting developer stream. I'm joined by Idris, like before, one of our friends over at Axelar, and today we are going to be exploring the gas estimation service that facilitates interchain communications when we're setting up those interchain tokens like we were talking about during previous streams. So make sure to check one of those previous streams if you want to see about all that. But this is extremely exciting because it's a very important component of how we perform all of these cross-chain functions while really only interacting with a single chain at any given time. So without saying any more, Idris, welcome to the stage. How are you doing today? We're delighted to have you here. And how are you doing?
Yeah, I'm doing great. Hi, everyone. Thank you. Thank you, Phil. I'm really excited to be here again today. And then we'll be talking about something very interesting and to share everything happening under the hood, what you should think about, and then also how gas estimation optimization work with Axelar. If you're trying to make a multi-chain transaction, what should you consider? What are some of the optimization you should think about, and also best practices? And of course, SDKs that can allow you to get accurate estimation and you don't have to worry about paying too much or way less than what is expected.
Absolutely. Now, we were talking just a little bit before the stream, and one of the things I asked is, haven't we used this previously when we were going through ITS and some of those related things? And Idris informed me that yes, we have, but we only used the GUI option, the graphical interface option. This is going to take this a step further and show us how to do it programmatically. Am I correct?
Yeah, that's correct. That's correct. We're going to see what is happening under the hood. We've tried to use we've used Axelar scan, and then we just like click on the button here and there to fix our stock transaction. But this time around, we'll be sending a request directly to the API and then doing all of these things and practically implementing them and seeing them work live in action.
Beautiful, beautiful. Well, I understand you have some slides to share with us today. Are we ready to pull those up on screen here?
Yes, yes, please.
All right, here we are. And I'll go ahead and put your portrait on top there. Take it away, Idris. I'll chime in here when I feel like I've got something useful to add, but otherwise the floor is yours, sir.
All right. Yes. Okay, yeah, you guys can see my screen. Yeah. Okay, yeah. So welcome once again. Today we'll be talking about multi-chain gas estimation and optimization with Axelar. What are some of the things you should know, and then how you can navigate through when building your decentralized application, some of the considerations you should think about, and best practices. So moving on, my name is Idris Olubisi. Once again, I am a developer advocate at Interrupts Lab, working on the Axelar network. And you can find me on all social media platforms at Olanesoft. All right. So what are we going to cover in this workshop today? First, we'll go through like the basics, like what are gas fees, how does gas fees work, like the flow, and then what you should think about. And then we'll talk about like the multi-chain reality, what happens when you're trying to send a transaction from one chain to another, when you're trying to communicate to from chain A to chain B. And then we'll also look at the pain points. What are some of the considerations? How easy it is for you to do it today? What are some of the options available? And then we talk about multi-chain solutions. What is the solution that we have out there that can help you to fix this? And we'll finally now talk about like the estimation and optimization strategy. And then we'll move on to the hands-on implementation where we get to see some of these things in action. And then, of course, after that, you can, implement them yourselves. All right. Yes. So thank you guys for joining us again. I feel like a lot of GM guys. So to get started, I want to give you guys a scenario and then paint a picture so that you guys can understand what we're about to do today. So imagine planning a road trip that spans different country. And then, of course, it's a road trip. You need to deal with things like fuel, and then fuel prices are different in each country because of of course, it's different countries, and then also payment method varies. So you need to use like a credit card here, use cash there, or even have a special local payment app in other places that before you can be able to like get fuel. Now imagine while you're traveling, the price of fuel, changes constantly, like, and also it varies from different countries. And you are never quite sure of how much you will spend before you reach your destination. Of course, you don't have an idea, but you just have to like prepare enough. So this is similar to the challenge when it comes to like multi-chain gas estimation and optimization. Just as it is hard to predict like the fuel cost across different borders, it's the same thing managing gas fees across different blockchain network is very complex. So each blockchain has its own pricing fee and structure, and also fluctuation that can go with network congestion and some other factors that could drive up the cost. So that's where Axelar comes in and then help you solve this problem. But then acting as a universal travel card that adapts to each country's payment system. But then not just adapting, but making it easier for you to make payment and you don't have to worry about what if I get to this country, what should I do? Helping you navigate all these gas stations across different chains and then also optimizing your cost as you go, which means that it is predictable. Like you can predict a particular cost, get the estimation, and then pay for it upfront without having to do with any other problems as you move from one country to the other. So in this case, from one blockchain to the other. So in today's workshop, we will explore how Axelar simplify this gas estimation and optimization, and then helping you make multi transactions smoother and more predictable. So now let's discuss like gas fee. What exactly are gas fees to get started with this whole presentation? So what are gas fees? If you are hearing gas fee for the first time, it's okay. If you're already familiar with gas fee, that's fine. But to keep things simple, gas fees are transaction costs on blockchain. So I'm using Ethereum, for example, here, paid in Ether, that's ETH for the currency, compensating validator for network security. But it's also important to know that gas fees fluctuate based on supply, demand, and network capacity. It's not just a static value that you can always assume it's the same any day, anytime. And it may increase during period of, any period of network congestion. Of course, different blockchain have different, way of approaching things. But then, what is a typical gas payment flow? Let's talk
For the
about it.
benefit of anybody who's hearing this for the first time, I just
Yeah.
wanted to say that a lot of times the best way to visualize this when you're getting started is like a on-chain auction where each block, the amount of space available within that block is essentially auctioned off. And if somebody puts in a higher bid, even in the last second, that bid may circumvent other ones, pushing them not out of the way completely, but into the next block or the next block auction, as the case may be. Back to you, Idris.
Yes, thank you very much. So now let's look at a typical gas payment flow and then what it looks like from the user perspective to calculating the gas, and also when the transaction enters mempool, validators, and all of this process. So this is a visual representation I created like to explain the whole flow. Then starting from the user wallet. So let's start with the user wallet here. When you want to perform a transaction on a blockchain, like sending tokens or interacting with a smart contract, yes, the wallet initiates this process, and then it goes straight directly to the calculator. So this calculator serves as something that estimates the amount that needs to be spent. So you could think of connecting your wallet like MetaMask or any wallet, and then you get this calculated this estimation. And it's very crucial because it determines the computational cost for your transaction. So think of it like estimating fuel that you need for a car journey, right? So it calculates, but the calculation here is based on base gas unit required for the operation, the current gas price based on the network demand, and then the total estimated cost in native tokens of that particular chain that you're interacting with. So you move from that and then go straight to the mempool. So mempool here, so once calculated, your transaction enters the mempool. Think of this as a waiting room for transactions. And then here, your transaction waits to be picked up by a validator based on the gas price you're willing to pay, the network congestion, the transaction priority, and all of these, other factors. And then go straight to like validators, where these are like, you can say miners before now, but because most of our the popular blockchain system now uses proof of stake. So you can say, validators, who are the network participants, and then they help process this transaction. But then they also have a way or an approach of selecting, this transaction. So they select directly from the mempool. They prioritize based on the gas payments and also execute this transaction, and at the same time distribute gas fees depending on what the distribution pattern looks like. But then if you look at this validator, you can see two arrows going to like base fee and then priority, which I just mentioned, where transaction gets picked up based on different conditions, right? So, but then when you think about base fee, this is a network determined minimum fee that gets burned or removed from circulation depending on the implementation. And then the other one here is the priority fee, which is like a tip that you give to validators to incentivize them to process your transaction even faster. And then of course we have like the burning mechanism, but I know this varies from different blockchain, right? How they tend to control the gas payments. We've seen blockchain at some point doing halving after every period of time for rewards, and then some implementation with burning the whole gas cost at the end of the day. So, but the burning mechanism, the key, it's functional and it's very key to economic feature that it helps control the network congestion, helps reduce the token in supply over time, and also makes the native token deflationary, which is something very, very important when it comes to like blockchain ecosystem generally. But then this is the typical gas payment flow if you're dealing with one chain. What about if you want to deal with like two different chains or three different chains at the same time? You want to send message from chain A to chain B to chain C, or you want to send a message from chain A to chain B and then make it like a two-way call. After an acknowledgement is made on chain B, you want to send it back to chain A. What are some of these interactions? How do you handle gas payments from different chains? So there's a reality when it comes to like multi-chain. Dealing with multi-chain is not as simple as what I just explained, where you deal with like one blockchain and then you try to estimate gas, make gas payment, and that's all you need. So what does it look like dealing with like multi-chain? The multi-chain reality here is that you have a bridge here. This is just an example, and then you either have to deal with maybe sending a transaction from Ethereum to, let's say, Avalanche, for example, and then you have to deal with gas payments on Ethereum. If the bridge is also a network themselves, you have to deal with paying their native gas payment. And then if you also have to think about the destination chain, in this case Avalanche. Even if you are going through, let's say, Binance to via the bridge to Solana, you have to think about the native token for Binance, native token for the bridge you are using. If it's a network that also charges on native token, I'll be going deep on that later on in this session. And then you also think about like Solana, what is the native token there? How can you make this payment? So it's kind of complex because you have to deal with everything at every point in time. So, but if you look at it from user's perspective, if you look at it from like developer experience perspective, if you look at it from user experience, this is very hard. This is a very hard system to build, and then trying to pay individual gas. Because it means that if there's any approval that you need to click on your wallet, you have to do it like, if you want to deal with like 3 chains, then you have to click that approval like 6 times. Because approving the transaction and signing the transaction, approving the amount that you want to pay, that's 2. And that's for 1 chain. And then you do that for the second chain, you do that for the third chain, depending on how many chains you want to interact with at the same time. So which is very, very complex because users have different way of thinking about things, and we don't want to make all of this process really hard for them to think about.
And also just wanted to reiterate there, Idris, that even when the asset is the same between both chains, unless it's a L2 that shares security with the origin chain, oftentimes you need to perform a swap in order to even get the same asset over on the destination chain, further complicating what you were explaining there. Great explanation, though, because I completely concur that this is very complicated. I'm excited to hear how we simplify it using Axelar tools.
Yeah. And also, I also want to point out, like, we have 5 things to think about here. which is very important to also talk about. So first one is like the user perspective. User needs to hold and manage multiple tokens for the gas fee across different chains, just like you mentioned. And also now you also need to think about chain diversity. Like each chain has its own unique token, gas token, price mechanism, transaction speed, fee structures that are different. The third one is bridge operations, like cross-chain bridge also add their own additional costs, and also which is like a multiple step. And the fourth one here is like the network state. Each network state affects like the current gas price and transaction processing time, which are some of the things you also need to think about, and the overall transaction cost. And then finally, the cost implementation, because you are moving assets, it means that if you want to add up all of these costs that I mentioned, it means you need to do like multiple gas payments. You need to also consider like different price volatilities, and various network conditions that would affect the price at every point in time. So on different stage, you have different things to talk about. But this is what the reality looks like. Now let's talk about the pain points. It's painful because um, you can think about this as a developer, and then because you're a developer, you're familiar with some of this integration, you can just build them. But if you look at it from like a user perspective, a user that doesn't have any idea about the type of tech you're using, they just want to use your application and they want to have a great experience using your application. So what are some of the pain points here? First is cost unpredictability, right? Because gas prices vary dramatically across chain, and there could be like network congestion that impacts fees differently. Multi-chain gas tokens, which you need to manage, and also you also need to manage the price volatility of that particular gas token. So it's very like one of the biggest points here is cost unpredictability. And the second one is technical complexities, right? Because you're a developer, it doesn't mean that you should go through like a lot of stress before you figure out how you need to manage this thing. So you need to think about different gas calculation method per chain. You need to, there are varying transaction confirmation times. There are chain specific transaction value failure that might occur during the process of trying to get an estimate. There's also nonce management across chain that you need to do. So these are things that you need to consider when you think about like how to handle multi-chain gas experience. And then user experience is first on this list, like which is very important. You have a lot of user experience issues, because just like the scenario I created earlier on, where you have to sign a transaction and you're signing, because you're interacting with like two chains, you get like a pop-up to sign like 6 times or 4 times, depending on how the implementation is, for you to sign the transaction and also approve the amount to be spent. So in that case, it means that you need to hold multiple gas tokens. That's number one, which is very hard. You need to hold like a native token for different chains that you're interacting with. Complex transaction tracking. It's very hard to also track transactions, because of course they are going across chain. You need to build a system that can efficiently track this transaction. But what if it fails? What happens to your gas costs? What are some of the things that you should think about there? What should your user do when their transaction fail? Are they going to reach out to support, or they just click a button on your UI and then move on? And because with all of that, it's very difficult to also estimate like the total cost, and which in turn gives like a not so great or very bad user experience at the end of the day. And then the final two here is, of course, I'll talk about the user. The developers also needs to smile. Like it's very important, because I'm building this product does not mean that I have to go through hell. So I need to also smile during the process of building. I don't want to deal with all of these things at the same time and then still be experiencing inconsistent accuracy responses, cross-chain handling, error handling, different gas estimation API. I need to estimate gas for this chain. I need to estimate gas for that chain. This is like a big hassle, because if you think about it, if the developer life is easier, then it means that they can think about the user experience even more than they think about like rewriting all their infrastructure. Because if their life is easier, if you just want click API, they need to integrate. That means they are not going to spend much time about thinking how to implement, but they will spend much time thinking about how to make their users' life even better. And then last on the list here is security concern. Of course, security means that you can, in this case, you can double spend. yeah, you have double spending risk, and also if your transaction fail, means that you need to retry. But where does the cost go? Yeah, you've lost money or you've lost assets at that time. Smart contract gas refine Griffin actually, maybe MEV exposure across different chain also is something to think and consider when you trying to do like a gas estimation, because you don't want to open your application up to like vulnerabilities. You also want to make sure that you have proper planning and then proper implementation, verified, tested, battle tested, and every other thing you could think of before shipping that to mainnet.
For
Yes.
anybody who's not familiar with that term, MEV stands for minor extractable value, in which the node operator or validator, if you remember our chart from the previous slide, actually introduces their own transaction before yours, increasing the cost of your transaction, but then enriching themselves in the process. And so this is something that needs to be mitigated by blockchain users and is through a variety of different methods. I'm sure we're going to get to exactly how that works with the Axelar method. I also wanted to point out, great question here from Bello, asking for deeper details. We're getting to that in just a second, so stick with us here. Idris, back over to you.
Yes, we're getting to that. So, like, I just want to like paint the picture, and then everyone gets like clear understanding of what it is to what does the gas fee means, and then what are some of the pain points when it comes to like multi-chain. So, what exactly is the solution? How can you fix all of this with ease without additional problems or without having to do much? What is that thing that can help you achieve this? And that's where Axelar Network comes in. So, I want to paint another picture here. Axelar network is a network on its own, right? That helps you facilitate, different cross-chain communication. But then, because we know this pain point exists, we try to also solve it and help our builders successful. And that way, we are confident that if they are happy, we are happy. So we are building not just the infra, but also thinking about the DevX and then how they can do it. So yes, Axelar, in case you're hearing Axelar for the first time, no worries. Yes, gas estimation and optimization can be done with Axelar. But before then, let's quickly talk about what Axelar is today. And then to keep it simple, Axelar is a Web3 interoperability platform, and it's an open stack for connecting all blockchain. With a single click, you can use and also build anywhere. So this means that when I say single click, it means that we have like infra, we have toolings that can help you just interact with our APIs, and then you can incorporate that into your application where user gets to click, and then they don't have to think about anything. Every other thing gets handled automatically. As you can see like different stats here. We have connected over 60 plus blockchain, 75 active validator sets, and since we've gone on to mainnet since 2022, processed over $9 billion transaction. And this is just to give you like a background context about what Axelar is today. And you can find all of these details on axelarscan.io, where you can see all of these things in real time. So to keep it simple, Axelar Network is decentralized focused. Axelar Network is integrated to 69 plus chain today. And that today with this implementation, because we have a lot to roll out in next few weeks, and which means that we are also going to have like a lot of chains connection. And aside that, it's very simple to use. We have so many toolings provided to you, API and SDKs that you can integrate into your application with ease. So now that's what Axelar Network is. How does Axelar Network help with like gas estimation and optimization? We have something called the Axelar. We have something called the Axelar gas service. But before I get to like talking about the gas service, let's talk about what gas estimation and optimization looks like to you, or like what it is today. So it means that you want to be able to like predicting and calculating transaction costs across different blockchain before execution. Of course, thinking about the gas unit and the gas price. And you also want to implement efficient, patterns and strategy to reduce gas consumption and cost. Yes, this is very important because that's the whole point of estimating and also optimizing for your users. And then you also want to have like a real-time monitoring and adjustment of gas fee based on the network, conditions. So what if something change on the destination chain? How can you track that? How can you monitor the transaction state? How can you know if this is successful or it failed? What are some of the optimization you should think about? And then what if you get a successful message or like a failed response? How can you reinitiate the process again? Are you going to start everything and then lose the fund, or are you going to just click a button or like integrate something that can unblock the transaction and then make the whole flow goes through end to end? What are some of and finally, yeah, essential costs. It's essential for cost efficiency, transaction success, and optimal network, performance. So when you think about gas estimation and optimization, it's important to know that all of these things, works hand in hand together. Which leads me to like the next point where we get to talk about the Axelar approach to multi-chain gas estimation and optimization. So first, we have something called gas service. Gas service is a smart contract that manages payments and also refunds for cross-chain communication on the Axelar network. So what do I mean here? It allows any application to prepare a gas fee on the source chain and increase the gas paid for a transaction. So an example here, if it's too much, if the gas is too much paid for the transaction, to calculate and also refund back to the sender. But then gas service is a contract. Estimation is different from leveraging the gas service. We have the SDK that allow you to estimate gas. So to even avoid, overpaying your gas for any reason. So if you use that estimation, which we are going to use here in doing our demo, then it means that you can get the estimated amount of gas that is required for that transaction to go through. Either you're going from L1 to L2 or you're going between L2 chains, you will be covered. Like you'll be rest assured that yes, this amount of gas is okay for this transaction to go through. So I also want to talk about something here about how we kind of use the connecting piece like the Axelar gas service. So let me give you a typical example here. You want to send a transaction from Ethereum to Base, for example. So you initiate this transaction from Ethereum. It's going to go through Axelar, right? Ethereum is a network. Axelar is a network. Base is also a network. So when I mean network, like they're all blockchain network. So you initiate transaction from Ethereum and it goes through Axelar and then it goes to Base. It means that you're interacting with different blockchain. So first, you need to think about paying native gas on Ethereum. You need to have it. You need to think about paying the native, gas on Axelar network. You need to think about AXL. And you need to think about paying native gas on Base. So those are three things that you will be thinking about by default. And this is very hard because back to our pinpoint that we mentioned earlier on, it means that you have a lot of things to think about and a lot of work to do. But how about you have a system that can just take one native payment from you and then handles the rest, which is what the Axelar gas service does. So you don't, instead of paying like 3 times, all you do is to pay once with your native source token, and then the rest will be handled throughout the whole transaction life cycle. So it means that if I have, maybe I want to send hello world or like, hi, Moralis team to Phil, for example, on Base, and I'm on Ethereum, and all I just need to do is to pay the gas fee once on Ethereum, and I'll be rest assured that you receive the message on Base. So I have nothing to worry about when it comes to like the gas cost that I need to pay Axelar, or the gas cost I need to pay Base, which is my destination chain in this example. So this is not limited to like Ethereum to Base. You can think of it like Ethereum to Moonbeam, Moonbeam to Avalanche, Avalanche to Polygon, any connected 69 plus connected chain as of today. So that is what the gas service does. But that's not all. Let's talk about the query API that empowers developers to even build sophisticated application and then making it easier for developers to use their platform. So this is an example of what the gas service code looks like, where you import the gas service contract and initiate it here, and then you call the function called pay native gas for contract call. So pay native gas for contract call in this case because I want to send Phil hello world or like hello Moralis team on Base, in my example, and then because that's the contract call, that's just sending a message. So I'm calling this function called pay native gas contract call. I'm passing like the message of value to when this function was initiated, and then I'm specifying the sender the sender of this, like the person that is initiating, like sending this gas value. And then I'm specifying the destination chain, specifying the destination address, specifying the payload that I want to like pass in, and then finally specifying the message of sender, which is the full refund address. Because remember, I said if you overpay for any reason, there will need to be like a refund at every transaction cycle. But how does the system understand where to refund to? This is where you specify the refund address. So I specify message of sender here because I'm just defaulting it to whoever called this method. But you can of course specify an address that you want all your refunds to go to. Just make sure that it is specified here in the contract, and then you don't have anything to worry about again. The system handles the rest automatically. So going back to the Axelar,
I actually have one question on that, Idris. So when you're specifying that refund contract, and maybe this is something we'll get into more when we're doing the demonstration, but does the refund address need to be on the same chain as the origin address, or can we refund to a different chain entirely?
yeah, so to a different chain, I think what matters here is the address that needs to receive it. And because you are paying native currency, like native gas for that particular chain, so the expectation is that the asset that will be sent needs to be also on the source chain. So for an example here is if you are paying in ETH, right? And then it's on Ethereum and you have an address. So what you just need to think about there is the refunds will also be in ETH. So if we all have other chains that also use ETH as a native currency, so which means that ETH will also be valid on all of those chains.
Perfect. That's what I was thinking, but I wanted to get a little clarity there before we went forward.
Yeah,
Back to
that's
you,
a
of
really
course.
good question, because you need to know like what if you specify another chain, if the native token that you paid is also like valid or like usable on that particular network, then it should be automatically available because the refund will always be based on the native token that you pay.
Perfect.
So now let's talk about adding gas via Axelar gas service. How do you get to add the gas? What are some of the things you should like? What are the options available to you? So there are different ways to add gas. So if you want to add native gas, the one I showed you guys now is the one you can just call directly on your contract. But if you think about functions that are available to you, let's say you have the transaction hash. For example, your gas is currently stuck, or your transaction is currently stuck. Sorry, not your gas. Your transaction is currently stuck, and then you want to add more gas. Looking through the Axelar scan, you realize that yes, it's showing that insufficient gas. You need to add more gas for this transaction to go through. Then how can you do that programmatically? Of course, you can do it directly on Axelar scan. We made life really easy for anyone to just click a button and then top up gas. But what if you have building your own application, or you built your own application, and then for some reason the gas your user pay is insufficient? How can you give feedback to the user? Let's say the user gets like a notification, hey, you need to pay, the gas you paid is insufficient, and then you need to add more gas. What is the CTA that you send to them? Oh, yes, the gas is insufficient. What should the user do? Or maybe you sent a mail and then give them a button to click, or you toast a notification, and there's also like a call to action. You need a call to action for the user to unblock.
Right. And ideally, it's giving them some kind of option within the DApp rather than just prompting them for a new transaction out of the blue. Because not that that wouldn't work, but then you're probably wondering, if you're the user, why am I getting prompted for another transaction?
Yeah,
Ideally, I can elect to do it at any point, with some sort of clickable button like you were mentioning.
Yes. So that button now is what that button will call underneath is one of these functions where they get the transaction hash for you, the log index, and also the refund address, right? And then once you click that button, it triggers this on the gas service, and then transaction goes through. You get a notification to add more gas, and after adding more gas, your transaction gets unblocked, and that's how you reactivate your stock transaction. And then we also have the other one, which is called add gas. The difference here is that you can specify the gas token, yeah, and also just the gas token that is different from just adding native gas, right? Gas token, gas fee amount. So these are the two functions available. If you check our documentation, you find like every other details that you need to know about like these two functions and which one you think you need at every stage of your implementation within your decentralized application. So now that's it for GAT service. So let's talk about the query API that actually allow you to make these calls on chain and then integrating all of these things within your decentralized application. So what exactly is Axelar query API? So Axelar query API makes it easier for you, but to keep things simple, Axelar query API is a JavaScript module that simplifies common queries for you to the Axelar network and some of the services it provides out of the box. And also providing easy to use functions for crushing operations and gas management. That's as simple as the query API. Think of it like any of your APIs that you integrate in your application. But in this case, this is particularly a module that allows you to query a lot of things that is available to you out of the box, leveraging the Axelar network and some of the services available. So how can you do this? Like, because I mentioned it the JavaScript module. So all you just need to do is to install the Axelar JS SDK, and then you initialize the Axelar query API here, which you can also specify the environment. So in this code sample, I'm specifying testnet because I just want you guys to see it, but it's not limited to testnet. You can also specify mainnet here to get the query. So what are the things you can do with the Axelar query API? First, you can do gas estimation across different chain, knowing all of this gas that is required for your crushing activity beforehand, before trying to do that. And also transfer fee transaction calculation. You can also make transfer fee calculation if you want to transfer and you want to know the actual cost that it will take you to transfer these particular assets. You can do it directly on the query API. It is going to return the assets for you or like the amount that you need. Asset denomination conversion. Maybe you want to convert from enum to token symbol, or like get from token symbol to know the enum. All of these things, like to know the denomination, all of these things are available to you. If you need like chain specific asset queries, maybe a particular asset, or let's say Binance or Base or any of these chain, you can just query directly and then get feedback. And one cool part here is the real-time network state queries. So the example that I made earlier, I'll give you like a notification to your users. How do you monitor like the network state query? How do you monitor if the transaction is stuck? Like, does a user have to go to other websites to figure out if your transaction is stuck, all in the name of checking the transaction state? No, you can track the transaction state directly in real time within your application without letting your user leave your application for any reason. So transaction state here, you want to know if the transaction is successful, send like a toast notification to your user. If it fails, send also a toast notification and then a call to action on what the user should do. What are some of the things? If it's still pending, you don't want to keep your user in a spinner, in a forever loading spinner page where they don't know what is going on with their transaction. You also want to tell them if it is confirmed, pending, approved, gas paid, all of these status that you need to track about your transaction and get your users excited. But then, sorry. Okay, yeah, so that's all the things that you can do with Axelar Query API today. And now let's talk about the gas estimation. I won't go through like the whole things you can do with Axelar Query API specifically, but I'll focus on the estimation here, which is the main purpose of our workshop today. So this is what it looks like for you to make an estimate, like make a gas estimate call. And in this example here, as you can see on the screen, we're sending from source chain Ethereum to Base in this example. And then what do I need to initiate this call? I specify the source chain ID, which could be like Ethereum, and then also the destination chain ID. I also specify the gas limits, the execution gas cost. I specify the gas multiplier because there are some cases that you need to buffer the gas a little bit. As you can see, the ratio here, 1.1 means that you want to buffer the gas by 10%. So why do you buffer because sometimes when you initiate a call, there might be a gas spike in the destination chain at the time because of there are a lot of factors that could contribute to that. But how can you cater for it even while you're trying to make the estimation beforehand? Of course, the estimation is for you not to like overpay or like get your transaction to be stuck. It's for you to make sure that your transaction goes through with ease. So you need all this estimation done correctly, and which is where you can specify your gas multiplier. And then you can specify also the source chain token symbol that you want to use, and then also the minimum gas price that you want to set. So these are all the details that you set, and then this gas estimates function returns the value in way for you. So now you can just pass in that transaction directly, that gas value that was estimated directly into your function call. So if you want to initiate that function call to do any cross-chain transaction, just specify the gas value that was returned here. And if for any reason there's also like leftovers gas from this estimation, you also get refunded because you've written, like you specified the refund address in the function call, which is what we talked about earlier.
So it sounds like the gas multiplier relates directly to what we were talking about earlier regarding the per block auction. So if somebody comes in following your gas estimate with a larger auction offering and you have the multiplier set, say, with a bit of an allowance, like 10% extra, then it's going to allow you to potentially stay in that block where otherwise you might end up in a situation where you need to add more gas later on. Is that correct? Yeah.
Yeah, that's correct. That's correct. You might end up in a situation where you need to add more gas. But if you already cater for it, like adding this gas multiplier, then you're good to go. You'll be rest assured that yes, the gas will be enough for the transaction to go through end to end. So with all of this, like we can't just talk about the query, the estimation, what happens under the hood without talking about how the gas pricing model works. Because you want to also know how is Axelar even doing this, right? What are some of the things they consider to make this estimation, and also what are some of the factors we put into place to make sure that we get the right estimation. So, which is the gas pricing? There is a gas pricing model. There's a flow that we use. We can find all of these details on our documentation, but I just want to quickly talk about it here. So, what exactly is gas pricing? So, transactions using Axelar often have like costs associated to with their source chain and the Axelar network and destination chain. Remember the scenario I created, like sending you hello Moralis dev on base, and then I'm initiating that call from Ethereum to Axelar and then to destination chain. So these are the things that we also consider when we talk about the cost associated to gas payments specifically. But there are different considerations that we think about. If you want to go from EVM to EVM, that we think about the different things. If you want to go from EVM to Cosmos, we think about. So for example, here we have the EVM to EVM. So EVM to EVM here, Ethereum virtual machine to Ethereum virtual machine compatible blockchain network. Here we are initiating the transaction on the source chain. What we do is after the initiating the transaction on the source chain, processing the transaction through the Axelar network, relaying to the gateway contract on the destination chain, and also executing the destination smart contract with the payload. These are all the payments that we make, and these are the payment considerations that we look into to help you handle your gas payment and make sure it goes through successfully. We handle 4 things here. But when it comes to EVM to Cosmos chain, because we also support Cosmos chain, we have Cosmos GMP, maybe Cosmos to EVM, or even Cosmos to Cosmos. We think about 3 things: initiating the transaction on the source chain. Yes, that's one cost consideration that helps determine the gas price. The second one is processing the transaction through the Axelar blockchain is another cost that we also factor in. And then finally, relating to an IBC or Cosmos compatible chain, which incurs like extra fees on its own, is also another gas pricing model that we look into, like we factor in before we try to initiate or like give you an estimate that you need for the transaction to go through. I'll pause here a bit to see if you have any question before I head over to demo. So with all of this, there are also things like execution fee, because it's something when you use estimate gas fee, why the estimate gas fee views the component of the transaction gas cost for you. It's your responsibility to also specify the estimated gas required to the underscore execute function. Let's say you are dealing with like a contract call by just sending messages. So on the destination tree, there's a function called the underscore execute method. So it's your responsibility to specify the estimated gas required for this. We always recommend that you use gas limit parameter in the gas estimation fee to avoid underestimation or like surprises fee. And you also need to think about the gas price volatility, where certain EVM chains have highly volatile gas prices. So to address this, it's advisable to pay extra gas amount upfront to prevent transaction getting stuck in the pipeline due to out of gas issue. Sometimes it goes out of hand, like some chains just get like gas spike seriously, and then there's no any other way you could do it than to pay upfront to avoid your transaction getting stuck. Even though if it gets stuck, you can implement this functionality to your DApp and allow your user to top up their gas or like add more gas to unblock the transaction, which offers like two parameters for this to improve like execution rate. First is minimum gas price for use on the destination channel. Second is the gas multiplier that we talk about to multiply the calculated value by a specified buffer for execution certainty. So that way you are rest assured that your transaction will go through. So having said that, we now need to like go through like the demo session where you practically see this implementation, and then we'll also like talk about some of the things you should consider when doing this. So yeah, what are we doing today? We are going to write a simple script to test GMP status. We also test recovery. We test adding native gas, and then finally we test gas estimation. All right, so I need to like switch over now to my Visual Studio Code. But before then, let me start with like what you need to set up first. Can you see my screen? Yeah, I think it's clear, right? Let me know.
Yes, I took it down for a second while you were switching there, but we've got it back up now.
Oh, okay. Fine. Thank you for that. So first thing you want to do is to create a directory. I created my directory already, and then I called it Multichain Gas Estimation Workshop. Feel free to name it anything. And then you also want to like initialize npm. You can initialize npm with this. I've done that already. And then next thing you want to do is to install the required package. We'll be using three packages here. And the first one is the Axelar network, Axelar GS SDK, right? And then we'll be using the ETAS package and the .env package to read our environment variable, which you can just go ahead and click install. Because I've done that before now. So what I'm just going to do is to switch to my Visual Studio Code. So now I'm on my Visual Studio Code, right? As you can see, like I've installed, I've also, the next thing you're supposed to do also is to, let me zoom in a bit just to be sure you guys can see my screen. Yeah. So the next thing you're supposed to do next is to like set up your environment variable and then just put in your private key because you will need that here. I've also done that already, and you can do that by just typing like touch.env, and then this should create this is touch actually. This should create an env file for you, and then you pass in your private key there. So I've done that before now, and then what we'll proceed to do next is to create a very simple index.js file. So this is what I don't have at this point. So let me try to switch my, bring this closer, and then go back here, and I can just do, instead of touch.env, because I have that already, I can do touch.index.js. Then I can go back to my file and see that I have index.js file now. Right. So there are a few things we are going to do here. First, we want to import and do like a very basic setup to start with. So the first thing we are importing here is the Axelar GMP query API, the Axelar query API, and also the environment variable. So let me close this so you can see this bigger. So we have this now. This is just one of the packages that we installed. And then the next thing we want to do is to also import ETAS from ETAS, right? And then finally, we want to load our environment variable. So we want to load the private key. So depending on what you name your private key, feel free to from the environment. Yeah, that's cool. So now you can just require like .env, and yeah, that's cool. Thank you. Yeah, so now we have this config that we import, and then finally we want to create a variable called private. I like to keep my variable like all caps, especially when it's a constant that is not changing. Sorry, that's the wrong spelling. Private key, and then we import it from our process. So what I named my own private key is this capital letter private key. So depending on what yours looks like at this point. So I have done that already. The next thing we want to do is to initialize this SDKs. So because we have two SDKs here that we're talking about, which is number one is the recovery API, and then number two is the Axelar query API. So the recovery API and query API is kind of similar to each other. So this is the recovery API, but they have like different functionality. So recovery API specifically, as the name implies, helps you recover a transaction that is stuck. And then query API does way more than just not to recover, but also to give you estimate and do some other queries like conversion from denom to a particular symbol. So we need to initialize the two of them, which is the query recovery SDK and also the query SDK. And I just did that right now. Similar, we specify like the testnet, the environment to testnet. All we're just doing here is to, the first one for recovery SDK, we initialize the GMP recovery API, and the second one we initialize the Axelar query API. So now this is the first thing that we need to do. So the next thing is we have set up with import and create like a very simple setup. The next thing we want to do is, which is our first implementation, is to try to get a transaction status. Try to get any transaction status. Right. So when you want to get transaction status, what we are going to do is to create a very simple method that can allow you to get a transaction status using our recovery SDK. So to do that, we have this simple method that takes in the transaction hash, and then we are logging a few things so that we can keep track of some details that we have. So the first one is we want to log the transaction hash, and then the next thing is we get the status from this transaction. So what we want to do is, let's test this out before we move on to the next implementation. So first, we'll create a very simple testing function that allow us to like test this particular function, which is our step one to get the transaction status. And then, but we also want to log the transaction hash. So we are going to do this together. So the first one is transaction hash, which is here. So let me try to get a sample transaction hash. So I'm going to go to axelarscan.io. Or no, I think I specified for testnet. So let me get the transaction of testnet. And then what I'm going to do is to go to like GMP SDK. Yes, I'm human. All right, so now you can see like transaction with different status executed and all of that. So, but then let me give you an example. We can also filter by status, like let's say approved. No, let me try. Could be anything, anyways. But then let's try if we can find any transaction that is waiting for confirmation. Yes. So now these are transactions that are waiting for confirmation. So I'm going to try. Let me try to filter to like a specific chain from and to, let's say, Phantom. Okay, this is the only one at least for Phantom right now. So I'm going to copy this transaction and then go back to my code and then do this, right? So now we have this sample transaction, and then I can just directly go back to my command line and then clear. And then what I'm going to do is I want to test this out now. So we can just do node.js. Yeah. And then we are going to run this. It says design function, a type error. Wait. Did you make mistake? Await get transaction hash. Yeah, this is correct. Is there something I'm doing wrong? Okay. I don't need private key here. Wait. It's not a function. She's strange. But it's fine. Figure it out. Okay. I'm not supposed to get type error. Let me just see. Recovery. I can just do this directly instead of calling this. Or maybe I should just call. Okay. I think I know what's going on here. Let me use a sample transaction and let me see what we're doing wrong here.
This is how you know it's live, guys. Anything can happen, and no matter what, we'll figure it out here with you guys.
And I think we did.
Okay, amazing, amazing. I knew you would.
Yeah. So I don't know. I think there's something wrong with that source that I'm trying to test with, but I found this transaction hash here, and then you can see, for example, this transaction that we try to get the status. So the status hash, this is it, and then this is showing that gas currently the status is gas paid. Yeah, gas has been paid already. And then we have like other information like where it is coming from, the details, the block hash, the chain name, the EVM chain type, the chain type, which is EVM in this case, the address, and some other information. And in fact, we have like the call TXS where you could track like the block number, the transaction hash directly within this call. And you can also find some relevant information that you might need within your application when you're trying to pull this record. So this is just a one-click solution, like a one-call solution to get the status of your transaction. If it is pending, you run like a pending transaction notification to your users. If it is completed or successful, you run a pending a successful notification. So all of these are things that you can keep track on your dApp without sending your users anywhere. So I'll pause it a bit. Let me do that. All right, so we have this completed. So we're done with like transaction status. So the next thing we want to do is let's push all of this down a bit so that we can implement the second function. But this second function, I want to showcase how you can manually relay a transaction on the destination chain. So you might be wondering, like, why do I need to even relay, like manually relay? So there are some cases where you send a transaction and then everything goes through, gas is paid, it is approved, it is confirmed. And then on the destination chain, there's some reason it got stuck. This is not because you didn't pay enough gas, or probably it might be because the gas got, like there was a gas spike and then it became insufficient in the destination chain. And then you now have to manually relay the transaction yourself. So for end user, manually relaying does not make any sense, because why do I need to open code and start? What if I don't know how to code? But for people like developers that build the dApp, after keeping track of the transaction, then realize that it failed on like the transaction failed on destination chain, then they can showcase a button for the user to click to manually relay that transaction, or they have a job that is running probably every 1 hour, keeping track of transaction and then manually relaying them automatically without having to tell your users to click a button and all of that. Maybe a job every 1 hour, every 10 seconds, every 10 minutes, every 1 minute, depending on the implementation and then how much transaction they are pushing every hour. So that way you can always be sure that you don't have a stuck transaction. Your users' transactions are always going through, and even the ones that got stuck, the job will pick it up and then manually relay the transaction. So the implementation is kind of similar because we are going to use the recovery SDK to also do this. But one thing that we'll do differently here is to call a different method. So in this case, let me push this down a bit more so that you can see this. Yeah. So in this case, for us to manually relay this function, we have two parameters we're passing in here differently. So the first one is the transaction art and the sender options. So the sender options, I'll show you what it looks like in a second, but something I want to call your attention to here is that we have this method called manual relay to destination chain. So if there's any reason your transaction got stuck and you want to like unblock it and then manually relay it with the scenario I created earlier on, then you can just call this function to retrigger the whole process and manually delay your transaction. But to show you what the sender option looks like for this particular call, which is something you can do yourself, right? First, we want to initiate the private key. We are setting our private key here, and then we are setting our provider. This is the sender option that I'm referring to here. And then with that, you can just pass it in and then manually relay your transaction. But because I'm not manually relaying any transaction right now, I'm going to like comment this out and then move on to the next step where we talk about adding native gas for payment. So if I want, let's say I want to add a native gas, I'm going to create a function and then I'm going to look for a transaction that needs more gas, and then we'll see all of these things in action. So let me take this up a bit and then function to add a native gas here. A native gas into a transaction. So it's similar function, but in this case, what we are doing differently is that we are calling the method called add native gas, also from our recovery API, because these are all recovery transactions. We are trying to recover an existing transaction and make sure it works fine, right? So I'll keep this for a bit and then so that we can go through it together. We have this, it takes in 4 parameters: the chain, the transaction ID, the transaction hash, the estimated gas used, and then the options. So here we are logging the transaction hash to see it. But then one important thing here is that we have like some callbacks here, which is the sources, the transaction, and then the error. And we are also using the recovery API, recovery SDK, to call the add native gas method, where we specify the chain, the transaction, the gas estimated use, and the option. So we are keeping track of these states here, success state. So if it's successful, then we want to log it. If not, we want to make sure that we are logging the error to see what happened and then how we can fix that within our code, right? So this is for if you want to like directly call it. So let me try to do like add native gas. So I'm going to like comment this out right now, and then I'm just going to await the next one, which is adding native gas to our transaction. But we need to specify a few things because we have about what's it called, chain, transaction, estimated gas use, and options parameter that we need to set. So for that we have different things, but I'll be using Phantom in this case. So for that we have all of these, and then we have the chain, the estimated gas use, which I'm limiting to 700K here, and then the provider, and also the option where we pass in the private key. And sorry, this is wrong. So we have the option. Let me type it in myself. Options, and then this option we have, first we want to specify the amount. That's the top up amount that we want to add for this transaction, and that's going to be let's say I'm just going to add the total, like this is in way, yeah. But let's move on, and then I'm going to specify the refund address. So I'm going to specify the refund address, but I don't think I will even pay more to expect a refund. But then the transaction sample I will be using, I know it was initiated by me. So I know the implementation I made there, which I'm already calling message or sender. So at the end of the day, the refund is going to go to my address. So, but then if you have any transaction, if you want to be sure, you want to double sure that yes, you need to get the refund back and you want to know the address, you can specify the refund address here. And then the last thing we want to do is to specify the EVM wallet details. So when we specify the EVM wallet detail, then that's what we need for the options. And the next thing we want to do is to call the method directly and then pass in this parameter. So how do we call that? We await the add native gas and then pass in all of this information. And this is how we do it. So these are the implementation that we need to like follow to test the add native gas. But then remember, this is our old transaction status and it has already been executed. So let's go back quickly here and then look for the transaction that needs help. So let me quickly search my own transactions and see if I can find any. Okay, yeah, so I have all of these here, trying to look for the ones that have like maybe insufficient error message, something. Okay, yeah, so you see this is Phantom to Avalanche, right? So I'm going to copy this transaction and this is showing that it needs showing, let me show you guys so you see I'm saying insufficient fee. Yeah, so I'm going to go back here. Yeah, that's insufficient fee. So I'm going to go back to my code and then pass in the transaction hash there. So what we're about to do now is to add more native gas to make that transaction go through. So watch, this is the transaction here, right? So now let's go. Let's go back here, play our terminal, and then test this again. Okay. JSON RPC provider. I thought we specified this already. Okay. Let me be sure which version we are using here. 5.72. Let me see which version. Because a lot of things have changed with this. Oh, I think that's why. So the new version for ethers have changed here. So what I'm going to do for this tutorial sake is to I will just quickly downgrade this to like a version that works with that have JSON RPC provider objects that way, so that we can continue. So that's another thing to note. Well, ethers they do have like a lot of breaking changes, but then when you are dealing with like migrations, you should just consider all of that. So I'm going to install this, which is like downgrading it back to 5.72 instead of 6. One thing about it at 6 is that everything changes. They change a lot. They had a lot of breaking change in version 6. So some of these objects are not the way it is right now. So some of these this object like this, if you check it, might be that they've moved JSON RPC back to directly under ethers or something has happened. So let's try the transaction again and hopefully it works. Sorry, it's a mistake. So now it says adding native gas for the transaction, right? We're going to wait, let it complete. So this is the transaction here. This is the transaction, right? So it said add native gas completed. So let me copy this transaction. Let's quickly go to FTM, even before reloading that page. Let's go to FTM and then you see the transaction is successful and then it shows what 2 seconds ago. So we've successfully initiated that call to add more gas. So I'm going to refresh this page and then let's see what happens next. Let's give it a bit, let's wait a bit, because you can see that we also have a button, which is what we've done before. Like in our previous tutorial.
Yes, of course. That would be how you do it through the user interface then, as opposed to the way we've demonstrated programmatically.
Yeah, exactly. So gas was added successfully. If that gas is enough, then we should see this transaction, go through. If it's not enough, we'll wait like a few more seconds, because remember that I did not do any gas estimation, right? I had coded the gas here. So this might still not be enough, but then let's see. So if it's not enough, if we try to also click, we also experience like the same thing here, which is what we did. And then in case you missed like our previous sessions, this is how you automatically do it. So now the difference between the way we added gas earlier on and the way this is adding gas is that, you see, this one is adding gas and then doing an estimate of what we actually need, right? And then you can see I have this confirm button where it's giving me, oh, this is what we need for this transaction to go through. And then I accept it. But the one we did here, we are not using our SDK, estimation SDK yet. So we had coded it, and this might still not be enough. And this is not really the best practice, right? I just wanted to showcase like a common error or like mistake that we might make as a developer if you're trying to like reactivate or add native gas to any transaction. Now you can see it says what? You can see we no longer have the insufficient error anymore. The gas has been paid successfully here, which you can also track on chain 31 seconds ago. And you can see the transaction is now showing what confirming. So the error is no longer there. And then which means that we have successfully paid this transaction. Right. So that's how you can do it programmatically. But now let's go to the more interesting part, which is the gas estimation for a transaction. And if time permits, we'll try to see we can use this estimate to unblock another transaction. But then the main point here is that you have this function here that allow you to estimate gas. So I can comment this out for now and then add the other method. I'm going to collapse this a bit and then scroll down. So the other method I want to do now, which is to estimate gas fee, here is we are going to create similar function, but now we are going to be using something differently, which is the query SDK. We've been using the recovery SDK to recover this transaction, but now it's about time we use the estimate gas fee method on the query SDK. And just like we discussed during the presentation, where we specify the source chain, the destination limit, multiplier, and all of that. One cool thing also is that in the presentation I mentioned that you can specify a multiplier and then put like 1.1, which gives you like 10% of the total. Another cool thing is we also allow it to default to auto. So if you default it to auto, then the system automatically does the calculation for you. You can see how cool this is. Like, you don't have to add code or rethink anything beforehand. If you specify the required parameter for these estimations, you are most likely like 99% of time you get the value that is required for that particular method. So if the multiplier is auto, then it's going to utilize the amount that is required. It's going to look at it and then buffer it accordingly and then use it to give you back this estimation, right? So now we have this estimation, we specify the source chain, the source destination chain, the gas limit, and the gas multiplier, right? And then we log it. So what we want to do next is to go back to our transaction here, and so I have this. I can comment this out so that it doesn't like block us. But the one thing we should focus more on here is, maybe let me go up so that it's a bit cleaner in you guys' screen. Yeah, so what we should focus more here is that we want to await this estimate gas fee. And then you can see like the things we need to pass in. But then we're passing in. So I just want to do like an estimation of what it takes to send the transaction from Ethereum to Base, for example. So I'm going to specify Ethereum Sepulia to Base, right? And then how many let me confirm how many parameters we need to supply, because this is already auto, like I've already set it to auto, so I don't need to pass it again. The last thing I just need to pass here is the gas limit, which is 700K. So now, using this now, I want to get an estimation of what it takes to send a transaction from Ethereum Sepolia to Base, and then to make the transaction go through successfully. So now I have this implemented. I can just test again. So it's saying, did you mean Base Sepolia? Oh yeah, that's true. I mean Base Sepolia. You can see another error that makes life easy for you if you're using this SDK. So I mean Base Sepolia, because of course Goli is no longer supported anywhere. So now we all have Sepolia. And then I can go back now. Maybe I should just clear this to make it cleaner. And then so now I'm estimating the gas that it takes to send it. It says, since you did not provide the execute data, this API will not accurately calculate this required fee, as will not be able to capture L1 inclusion fee for this L2 chain. So what this means is that because it is L2, right, there is something when doing gas estimation, we also try to cater for L1 fee. You know, L2s at the end of the day, they batch back to like L1s. So we also try to cater for it. But then for us to know that you want us to cater for it, then you need to specify like an execute data parameter, and then you provide all of the information that you need to provide. And then you get the estimate. But still, this is what the estimate looks like if you want to transact and then send the transaction. So let me try to copy this and then go to like let's say a converter or something. Yeah, so I'm going to use this if converter, and then you can see the value is way. So if I pass in the value, it takes 0.0000000545 costs for you to send transaction from Ethereum to Base Sepolia. That's how you typically get an estimate. And then what you just need to do is, if we were to call this transaction again, so like if I go back to my transaction, you see the previous one that we did for adding native gas. So instead of hard coding this value here, I can just specify the estimated gas value here, and then I can run it. But because this is an existing transaction, it means that even if I try to do this estimated gas value, it might be a lot more, because you already paid the particular gas, and now I'm initiating a new estimated gas value. It means that might be more. But then you should be rest assured that after the transaction goes through end to end, there will be a refund that is going to happen, and then go back to the specified address. And that's typically how you do like gas estimations with Axelar, with ease, directly from your SDKs and also within your application. And also there are also some other things to consider when it comes to optimization. You need to think about like your contract level optimization. What are some of the type of method that you are using? Are you using storage? Are you using memory? What are some of the types that you are using, and then how you are using them efficiently? But after looking at all of those things, and you still want to think about like things outside your contract, then the best way to go is to use the estimate gas fee method on our API that allow you to estimate the value that is required for a transaction to go through from one chain to another. Be it Ethereum to Base, be it Base to Avalanche, Avalanche to Polygon, Polygon to Binance, Polygon to Arbitrum, Ethereum to Arbitrum, any of these networks, you get an estimate that is going to work to make this transaction work end to end at the end of the day. Yeah, so that's pretty much it for our demo. With all of the things like tools and this SDK implementation that you have in your hands, and then out of the box leveraging the Axelar query API, or either it's query API or the GMP recovery API, you have everything to you out of the box. So I'm just going to go back to the now and then round up.
All right. Well, thank you so much, Idris, for all of this information and an excellent demo. Before we wrap up, I want to make sure that people have the ability to reach out to you if they have questions while developing their own dApps and cross-chain tokens. What's a good way for them to get a hold of you?
Yes, I'm really active on Twitter. You can always reach out to me on Twitter at Olanesoft. Yeah, so, and also not just me personally, I'm going to share like a repo that you can have a well-detailed report. So Yes, I know you all might have questions, which is why I added this to the slide. Yeah. So for all the questions, you can just go to Axelar Network/support. So if you Google Axelar support, the first link you're going to see is probably the GitHub link here. I've tested it multiple times, so I don't want to say like it's first thing, but you should look out for this link, Axelar Network support. If you have any issue with integration, question, clarification, or you just have feedback to share, please feel free to create an issue on this support. We usually get like notification immediately after creating this issue, so we'll be happy to help you. So once you create the issue here, I'll be happy to support you, or any other person from the team will be happy to support you. And also, I also want to talk about the Axelar examples. Yeah, we know how difficult it is to like build and also look out for like sample code. So we've created this robust repository that contains a lot of examples, both EVM and non-EVM examples that you can find. Please take a look at Axelar Network/Axelar-examples repo, and then you find all you need there. And yeah, that is, my name is Idris Olubisi once again. And if you want to reach out, please reach out to me. And this QR code, I also open it up for anyone to please scan. Let me know what you think about this demo. Did you find it helpful? And have you been able to like understand how to do gas optimization and estimation on your own, leveraging all the tools that we provide out of the box? It takes literally less than 1 minute to fill in this survey, and I'll be happy to get all your feedbacks. Thank you. And I hope we don't have any questions.
We got one question here from Bello regarding contributing to Axelar development. Can that also be done through the link that you provided earlier?
If you want to, so there are different things you can contribute to. You can contribute to our docs. You can contribute to we literally have all of our projects open source. So all your contributions are welcome. All you just need to do is to create an issue, then send a PR, and then we'll be happy to review all of them. But the repo I shared earlier is particularly specific for support, right? If you need support to like anything. So even if you create a support request there and we realize that it needs to be moved to another repo, we'll also do all of that and help you move it to the appropriate repo. But that's particularly for support. You can contribute to our docs. If you find anything, typo, any improvement, things that you don't think is correct, please, we'll be happy to like get all of this feedback. These are the ways we've been improving our documentation over time, and also some of our implementation. And then we'll be happy to receive all of that.
All right. Well, thank you so much to all of you that joined us for the stream today. And an extra special thank you to Idris and the Axelar team for bringing all of this to the table for us to become better with our blockchain development. That said, if you're looking for help with blockchain development, you're getting started, or maybe you need some better tools, check out the links below. Over at Moralis Dev, we are here to help you and assist you with the best tools and the best partners in the industry. And on that note, we'll look forward to talking to all of you later on. Thank you again. And hey, Idris, did you have anything else for our viewers here before we wrap it up?
Thank you so much for joining once again, and we can't wait to have you next time. Yeah, we have a lot more planned, and then it's coming. Yeah, we have a lot, and particularly we also have from the Axelar side, we launch the Mobius development stack, which is Axelar MDX. There are a lot of things we're planning to roll out. Please look out for it. And also we have like a lot more videos, practical implementation like this one, workshops, things to talk about. So yeah, can't wait to have you next time.
Perfect. Well, thank you again, Idris, and thank you again to all of you. We'll see you in the next video.